Hello everyone, today we will learn about active and passive satellites and its orbits. Active and passive satellites are communication satellites. A communication satellite is a spacecraft that orbits the Earth and relays messages, radio, telephone and television signals. Stations on the ground are called Earth stations. Transmit signals to the satellite and the satellite in turn relays the signals to the other Earth stations. The first satellite to relay messages from one Earth station to another was SCORE. It was launched on December 18, 1958. Communications through satellite are either passive or active. The first communication satellite was passive. Passive satellites merely reflects the signals received from Earth station. In 1960, the United States launched the ECO satellite, a metallic balloon that reflected signals. Active communication satellites receive signals from Earth, amplify the signals and transmit them back to Earth. Nowadays, we use only active communication satellites. Now, I will discuss about the geostationary satellite and polar orbiting satellite. The figure depicts the main difference between the geostationary satellite and polar orbiting satellite. The polar orbiting satellite circles about 850 km above Earth's surface. On the other hand, geostationary satellite is at 36,000 km above the Earth's surface. From this, we can observe that geostationary satellite always looks at the same part of the Earth, and the satellite has to go around in a full circle about the Earth. So it requires a period of 1 day, that is 24 hours. Now we will derive the altitude of the geostationary orbit. Here, the orbit velocity is v. The radius of the orbit is r. The mass of the Earth is m suffix e. And gravitational constant is g. From the formula of centripetal acceleration, we know that the velocity of the satellite is equal to the square root of the gravitational constant into mass divided by the radius of the orbit. The period of the satellite is t, that is 24 hours. The velocity equals 2 pi r by t. So we get r cube equal to t square g m suffix e by 4 pi square. Now putting the value, we get the orbit radius r equal to 42,300 km. As we know, Earth's radius is 6,380 km. So the altitude of the geostationary satellite should be about 35,900 km, that is nearly 36,000 km. Now we will discuss about the advantages of geostationary orbit satellite. We can have full disk view of the Earth by the geostationary orbit satellite. It provides very high temporal resolution in minutes, so it can be used for weather forecasting. Now the disadvantages are it's too far for high spatial resolution as greater than 1 kilometer, and it produces distortion at poles. Here we can see the view of April 2014, Australia, the detailed temporal view from the geostationary orbit satellite. On the other hand, the polar orbit, it always passes the equator at the same local time as it is sun synchronous. It can be done with 100 minutes per orbit at 850 km above the earth. It is always ascending track, that is northwards, and descending track, that is southwards. Thank you.